This is the code for my water fountain. I was originally going to do a spout, but the making it start from where you are and like spray outwards was giving me issues. But this is where I developed the particle system that I have. So, as you can see, the part class is the particle class, and it comes with a float, which is a radius, and a position, and a velocity, as well as a max life and a current life, which is its current life. So a position is just a subclass or another class that has x, y, and z values in it, and then the velocity has the x velocity, y velocity, and z velocity. So that's pretty simple. And then each thing, or the particle class, has the display function, or it has two constructors, one that just initializes nothing, and then one that initializes the variables, as well as a display function, which does as it says. It puts it on the screen, and then using the push matrix and then translate of the sphere that it's drawn, and then pop matrix, and then it has accelerate, which changes the velocities based on inputs, and then move, which changes the position based on the velocity and the change in time. And then the compute physics is where the physics is done. And so this section right here has the acceleration in the downward direction, which is positive because it starts in 0, 0 at the top left. And then, as well as incrementing the lifetime that it's been alive, and then checking to see if it's collided with the walls or floor. And that's pretty much how the particle system works. And then here is the floor emitter, and that basically just has an x-coordinate, which is like the center of the circle, and it's a circular particle. It's a circular emitter. And then the z-coordinate, because it's on the floor, so it's an xz plane. And then the floor, and then it also has a radius, which is just how big the circle is, of course. And going with that, it has the methods generate position, which uses the rejection sampling on a square to find random points inside the circle. So it rejects if it's outside of the circle, but otherwise it just randomly generates them with a square, because the circle takes up most of the square anyways. And so that's done here, and then it just returns the position. And then the generate velocity is here, and this just generates a velocity. And it has a standard upward velocity, and then it randomizes its x and z velocities so that it goes in like a different direction and returns that velocity. And then, so in setup, I set up the window as well as the fill, so just the color blue, somewhat translucent, so that you can see that, and then no stroke and lights, basically. And then I do the time thing that you explained, or that was explained in class, and I initialize my floor emitter, as well as the parts, which is the part list, and all of these are initialized down here. My code is a little bit messy, possibly cleaned up when I turn it in, probably cleaned up when I turn it in, and then. So then the parts, each of them is just initialized so that you have something there to go from. I did this because there's an example on the processing website that recommended that you do this with the arrays of objects. And then the p generate is initialized here. I just have it at 37, so that's particles per second. And that's just kind of, this can be changed. And yeah, but 37 is where it's like a nice constant flow and takes up a lot of the particles. If this is changed to 50, it actually maintains 500 particles and does so right around 20 frames per second. And then, yeah, and then the draw basically calculates the time elapsed since the last time it was called, and then prints out the seconds that have elapsed and then the number of particles currently activated. So this is basically how to get your frames per second and then particles in it. And then calculates the number of new particles, generates from there these new particles, and then increments next, which keeps track of where we are in the particle, or in the particle array. And then this is the update loop, which basically checks to see if the particle's life hasn't passed yet, and then displays them and computes their physics using the time elapsed. And then, but if they are over their life, it gets rid of it, subtracts next, and then puts where next was, or is now, I guess, back where the old one is, so that it fills from the beginning of the array and goes down to it always. And that's pretty much it as far as my particles system goes. And this makes the fountain that's seen in the other video. And yeah, that's it.